Good afternoon, ladies and gentlemen of Algebra 2 Honors. Good to have everybody here today. We're going to resume in solving three variable systems of equations. And here we have the one we finished with yesterday. And as we finished class yesterday, I was looking at this and tried to solve, but I realized that I had made a mistake. And the mistake I made was I put negative j, 0, and I put just one d instead of three d's. But after I fixed everything, things worked out just fine. And so I bring that to your attention to remind us that in doing these things, it's easy to make mistakes and mistranscribe. And so just be open-minded as to what a wrong answer looks like. I think it ended up being like 20, 80, 20, right? Which really missed. So I recognized instantly that the numbers didn't make sense. So when you put these together, try to think of what numbers might make sense, because that could make your life easier, depending on what that is. You missed one? All right. Yeah, thanks, Marcus. Okay, but we're going to go on to number 13, and I want you to do that one, and I'll call on somebody for help in just a couple minutes. Are you able to fashion out three equations from this?
Yeah.
Very well. Anybody having trouble coming up with equations?
Kind of confusing at a time. On what to do next.
Did you make your equations though?
I have two of them. I think.
You have two of them?
I don't know if they're right, but I think I can get.
All right.
I'll listen.
Okay, I'm going to try to recruit some help. explanation for this. Okay, let's go here. Let's shuffle ones, here we go.
I have that one.
Addison, you have to do it this time.
Sadie.
It's like our first time ever being picked.
Yeah, I got the first the picture, and then I figured it out.
All right, Addie, what did you get for this?
I have A plus B plus C equals 1,000.
A plus B
10.
plus C equals 10,000.
10,000.
Okay, any questions on that? Okay, go ahead.
And then A equals 4B.
Okay, everybody sees that? Had is the equal sign there, and then 4 times B. Okay, good.
And then I have C equals A plus B.
All right, any questions on those? Okay, then you went ahead and solved the system too?
I was gonna try a substitution,
Uh-huh.
so
Okay, so what did you do for that?
I didn't do it wrong. I didn't do it right because I thought it said 1,000 instead of 10,000.
Okay, so you need to adjust your numbers, right?
So that's as far as I got.
I can take from here.
Solve for B.
I got it. Is it you? Let me
Now,
go.
one thing you can do, Addie, is if you used 1,000, that means that A and B and C, you just multiply everything by 10. And you'll have your answers, right? Because 1,000, 10,000 is everything divided by 10. So if you used that, you just have to multiply your solutions back by 10 and you'll have your answer, right?
Yes.
But so Addie, tell me what you did or what you want to do.
I don't know. I could do like substitute for A to make it 4B. So it would be 4B plus B plus C equals 1,000.
So that replaced 4B there. And then C, you can replace A plus B, but then in the place of A, you could go here, right? So C is equal to 5B, is that what you're saying?
Yes.
And then if you put 5B up here in place of C, you have 4B plus B plus 5B. So you got 10B is equal to 10,000. Is that what you're saying? So B is equal to 1,000.
1,000.
And now it's a matter of A is 4B, so A is going to be equal to 4,000. And then the last one we have is C is going to be the difference. So we got 4,000, 1,000, and this has to be 5,000. Anybody solve that as a matrix? And it worked out pretty well? Okay. To me, something like this where the numbers aren't that complicated, it's like, did the matrix solving help you that much? Probably not. But I sort of like doing it anyway sometimes. It's just
He was explaining to me how he did it with a matrix and it was confusing. I was so lost.
So who's explaining to you?
Ben
Oh,
was.
Ben was?
Yeah, I did it like that.
You did it more like that? Yeah. What you have to do on that matrix, you have to solve one side of the equation equal to 0. Okay, and then you got to line up all the other variables in place. And you'll generally be good, but even with that, it's easy to make a mistake, like I mentioned. Okay, what I want you to do is look at number 14. I'll choose somebody for number 14. And these other problems, remaining ones, are more sort of like thought experiment problems. So if you can think about that. We talked about this idea a little bit. I'm going to call on somebody in just a minute. So just be looking at 14 and thinking about about how you can know a system has infinitely many solutions or one has no solution. Okay, let's see here. We've got shuffle.
Oh,
So it's gonna be Ben. Okay, we picked a good one. I was kind of rooting for Peyton again, but this time it came up Ben. All right, Ben, what do you got?
So like whenever you solve the equation and stuff,
Uh-huh.
if the number equals a number like 15 equals 15,
Uh-huh.
that's when you know it has infinite solutions.
Okay, so let's go back and translate it into, like, for instance, Ben, you're talking about a problem like this one here, right? Where if we take these two equations together and we end up with, in this case, 0 equals 0, infinite solutions.
So when one number equals the same number?
Okay, that's infinite solutions. Because there are no variables at all, so variables don't matter, it just equals in any case. Okay, what about no solutions?
Is when one number is equal to another number. For example, like 15 equals 2. Or
Yeah. And what I did for 7th period is I just wrote an example of that. Let's say we have this situation, but let's say instead of this first equation being 2x minus y plus 3z equals 5, what if we make that equal to 6? And then we multiply through and cancel. Well, we'd have 0 equals 3, but does 0 equal 3? No. So here's an example of no solutions. Or no solution, right? So that's a pretty good explanation of that. And then we also saw that, didn't we, when we did the matrices? And we had those numbers not on one line, so that's what it looked like there, infinite solutions. So let's go ahead and look at number 15. I'll call on somebody in just a minute for 15. 15 is a what's wrong with this. So 15. Let's see who's going to help with 15. Here we go, number 15.
oh, not ready.
I don't know. I did this, but they did.
Okay, Jay, you got 15 for us, Jay?
I did 3 by 4, but
So
they did
they went
3 by
wrong because I didn't put the answers in the matrices. So like the 0, the -3, and the 12, they didn't put them in the matrices.
So you're saying these things should go here like this? And then like this? So this will be, how would you say this? Not a proper augmented matrix.
Do all augmented matrices have to be repeatable? Just depending on how many variables you have?
Yeah, it depends on how many variables you have. But there's another possibility too, is you can have, like what happened on problem 16, you'll see that. And then, what I had people do in the other classes is they actually used this property and solved it and got a solution for it. Did you do that? What'd you get for your solution, Jay?
Yeah, x equals 1.25, y equals 2, and z equals
Negative
2.25.
2.25. And then you use the matrix. Okay, good. All right. All right, good deal. Let's go to, I want you to think about 16. I'll call somebody for 16 in a minute. Okay. Let's go here.
I don't know if I did this right or if I guessed right. Well, it's because there's only two equations, so you need the third one.
So you have three unknowns or three variables, right? So three equations are needed, right? Is that what you're saying?
Yeah.
So that would be our answer for that one. I had people put in a 2x4 matrix to solve, and you can see that you have like free variables in there. But that's going to be your answer for that. Okay. Work.
Hey, Connor, you're great. Thank you so much.
Yeah, and what I want to do for the rest of class, we're gonna introduce systems of inequalities.
Yeah, well, I've got it ready.
Make sure your name's on the name of the paper, please.
Connor,
did you just say you were playing my house?
I didn't say that. All the people in the
This is on YouTube. You can't
What?
say stuff like that.
phone. I was taking my mom, told me I had
Oh,
practice
you did
today.
sheet up what? I was like, cool.
Oh, I forgot. Got yours. Okay, good work. All right. So I want you kind of, we're going to look at this next section here, which is solving systems of linear inequalities. Do you know what linear equalities are? Do you remember what they are? Has it been a while? No, so you shaking your head, right? It's been a while. I had people in 7th period, it has to do with the line, right? I had people saying, well, that was in 8th grade. That was quite a while ago. It really was, right? It was a while. So, That's what we do. We kind of cycle through, spiral through material. So what we do today shouldn't be a complete new language for you. So we're going to solve systems of two or more linear inequalities in two variables. And we're going to start out by this explore section. And it says, what does a graph of the system of inequalities look like? And it says here, start with the system of equations. You have y equals x plus 2 and y equals negative 2x plus 1. Graph the lines on the coordinate plane. Do you know how to graph the lines on the coordinate plane?
Yeah.
Yeah.
Yes. So let's do that. So we have, I'm going to make a blue line here. So this first one here, y equals x plus 2, how can we graph that line?
Go to 2.
2.
Y equals 2. And then like, the slope up 1 over 1.
Up 1 over 1. And we see the proportionality is the same. So I can go up 4 over 4, whatever, right? So you're looking at this kind of diagonal relationship here, right?
Yes.
And so the line's going to look like this. Kind of, I think I got that one off a little bit. That one point off here, yeah. But you can see that line is a little wobbly, but still we can see what it is, right? And next we have this y equals negative 2x plus 1. And what is that one going to look like?
Going down.
Y-intercept is 1, okay. And down 2 over 1. So 1 and down 2 over 1. So the thing's going to look something like this. Doesn't look quite right. Okay, down to, the way this thing is set up, it's kind of weird because that's 2 over 1, 2 over 1. Okay, I guess that isn't as bad as I thought it was. So things are going to look something like this. Okay, there we go. So it'll look something like that, right? I know that's not perfect. But how many regions do the two lines divide the graph into? 4. Now I want to mention something else about these lines. These lines are called boundary lines. Why boundary lines?
Boundaries or like borders between each section?
Yeah, their boundaries are borders between the sections. That's what Ben is saying. And the boundaries separate the coordinate plane into what is a solution, what is not a solution. So one side of the line a solution, the other side not a solution. And what about, okay, so it says, consider what it means to replace the equal sign with an inequality. Replace the top equation by the inequality y is greater than or equal to x plus 2. How is this different? How is this line different than just y equals x plus 2?
Because it can't be less than.
Because it can't be less than, right? So Marcus is telling us that this whole area underneath that boundary line is a set with no solutions, right? Is that what you're saying, Marcus? Yeah, he says hesitatingly. No, but that's right, isn't it? And so Marcus identified which side of the line the solutions are not on. What do we know about this other side of the line? We know that they are solutions. So what I'm going to do is designate that understanding by doing this with the red hatching, okay? Next, by the way, that's 4. Next says replace the second equation with y is less than negative 2x plus 1. And do you notice what I happen to do with the second line? I drew a dashed line, right? So what do we do to designate the proper solution set for this second inequality?
The left side, or the bottom left side?
Yeah, because what it is, less than, yeah. So it's going to be the bottom left side, so I can come up here. And so now it's relative to this dashed line. So I'm just shading in that whole area. And so how do we know what our solution set is now?
One with both.
Yeah, the one with both. And one thing that helps me, that it's going to be harder for you to do with the normal pencil, is I have some color, don't I? It's going to be this whole piece right here that I'm enclosing that way, okay? How much of this do you remember from Algebra 1? A little bit, maybe? Okay. Let's go on to this one here. Now, depending on what kind of calculator you have, but this is what happens when you get tests and so forth. This is what a system of inequalities will look like. That you'll have one area of the floor that's not shaded at all, one area with the solutions that's kind of dark, and the other two that are sort of medium. Okay, so this is analogous to what I drew earlier with you saw that with the red and the green hashing. And then you can see that this boundary line is y equals negative 1/2 x plus 2, and this other boundary line is y equals 2x. Now I want to go through just this last one here quickly, and so it says graph, we have y is greater than 2 and x plus y is less than 2. So how would you graph these boundary lines? Well, first of all, I want to solve this one for y, so that's going to be y is less than negative x plus 2. Okay, how do you graph these boundary lines?
Except on that one, you're going to do 2.
2, okay.
And you add that one.
Yeah, I'll leave it there like that. So 2 you say? And then we have 2, so negative x plus 2, so something like this. Does that look somewhat right? So negative x plus 2, there's that one, okay? What next?
Other one's the vertical line, right?
Yeah, vertical, right? We have an x equals 3. So here we have x equals 3. So like this. And I'm kind of drifting to the right on this one. Let me go ahead and see if I can somewhat fix that. Yeah, it's a little better, isn't it? So we have x is equal to 3. Would draw x equals 3 with the dashed lines. But what next? So for x equals 3 and for negative x plus 2, what next?
start shading.
Start shading, okay, which way do you want to shade?
Everything on the right of the vertical one.
Everything to right of vertical line? Yeah. And then what? Y is less than negative x plus 2, what do we do with that? Everything underneath. So I'm going to go with this yellow here. Yellow's not very visible, is it?
Not really.
Well, you can see the solution set, right? This piece right here. So here's your solution set. So it's this piece right here in lower right. Any questions about that? Is this pretty simple? We're going to be going to do some exercise on that now. Your calculators, some of them have different facilities for doing this, and we're going to kind of maybe flesh that out a little more starting on Monday. You guys that have the CE calculators can have your calculators do that automatically. The ones with the TI 84 Plus or Plus Silver Edition, there's like an app that will work with this that we'll talk about. It's called Inequalities. The calculator comes with standard, but so we'll just kind of leave it there today. Any questions? All right. I hope everybody has a great weekend.